nice little vid for you today. I am going to demonstrate for you guys what happens if you use one of these and the voltage is more than 240 volts. And of course, us boys are now little toys, it normally is. So we'll have a look at the hazards that you might expect if you did use it. I wouldn't even use one of these for domestic purposes. Use a proper tester, not these things. So let's have a little look, and there will be flames. That is a certainty, because I've already done it. Here's our screwdriver in bits as usual. 240 would normally be there, travels to the top of that. It then goes through the neon, through the resistor, through the spring, out to the top, and then unbelievably through you. And then, when there's a small current flow, that neon will illuminate. But the problem is, that neon and that resistor will allow full current flow if you get up to 1,000 or so volts. There will be no resistance left in that resistor. It will jump that and that neon, and you'll have the full lot coming out the top of that driver. And you'll be hanging on to the end of that, wondering what happened. Number 2 problem. If you drop that screwdriver in the sink or a bowl of water, you're probably inclined to take it out, put it on the side and forget about it. But if that thing's full up with water, once again you'll get the whole lot coming out the end. Not nice. Of course guys, it's the same thing with these battery operated continuity testers. You'd have a couple of batteries in there and an LED. Again, unwise. Don't even have one in your toolbox. Should we bust it? We're going to do another test with a replacement finger, slightly more impulse current. In fact, quite a bit more. I popped it. More bolts. Let's discharge this thing first. Oh, it's quite loud. Oh, it's melted. Oops. Oh, I do like doing that. I think I've demonstrated that, gents. Ooh, it smells of burning flesh up here. Now then. Oh, might have upped the volts a bit too many. I'm now going to do the same experiment, but with this screwdriver. Yeah, only 1,000 volts, but guaranteed at 1,000 volts. I'm sure we can find out what the actual limit of these things are. So So I think we'll first try it on 8,000 volts. Luckily guys, I have a replacement finger. Let's see if that screwdriver can protect it using 8,000 volts. Not bad. I'd be a lot happier using that driver, I tell you. Well, we know this screwdriver's designed for 1,000 volts, and we had it on about 8,000 volts, and there was no leakages, but that doesn't mean to say it's designed for that. Out of interest, and purely out of interest, I want to know what these screwdrivers can actually withhold. So I'm going to put it on 15,000 volts and see what happens. I can hear it. So it's there, and it's still holding that lot back. Unbelievable. It's not meant for that though. But everything has a breakdown resistance. Let's find out what voltage it collapses at. About 50 kV now, 50 kV. Doesn't like it. Must be a weak point in it somewhere. But it's where that shaft joins the handle. Unbelievable. That would probably feel quite funny if you did do that. Be a bit fizzy. Alright, more volts. Now we've got well over 100,000 volts. Game over. There's your weak point. Once that happens, that's it. Throw it away. But that did extremely well. I'm impressed. Better than that silly thing. Well, I don't know why it is, but I still enjoy experiments like that. It is slightly educational, it's a little bit amusing, there's a bit of destruction. Now look guys, I don't ask for much on my channel, but what I will ask is that you just play safe. Yeah? If you can help each other in the comments, get in there. I'll see you in there in a minute anyway. Cheers guys.